It's on the back of the one that's in the tray right now. Okay, so this would be 36 times 2. 36 is the perfect square, right? So it can come out. What's the square root of 36? 6, and then the square root 2 stays behind. We did find your test, Sipey pen. When I accidentally gave it to another student. I gave it to Zazing instead of Zapen. And yours. There you go. So sorry, but thank you for your patience. Okay, 256 actually is a perfect square. If you put that in your calculator, what do I get? 16. So how do I multiply? What do I know when I multiply two square roots that look exactly the same? What happens? Oops, I didn't want that to pop up. It just cancels the radical, right? Um, so when I do this one, it's going to be 5's on the outside times square root 6 times square root 6 is just 6. So then I multiply that 5. This should be 30. Oh, I don't know why this thing keeps popping up. Okay. Yeah, I'm just waiting for them to sit down. Okay, so what happens when I have a square root multiplied by itself? That's a perfect square, so I'm just going to put 5. Because square root 5 times square root 5 would be square root 25, but when I take the square root of 25, it's 5. Those radicals cancel each other out, right? So let's look at number 5. This would be square root 50, which is just 25 times 2. Yep, 5 square root 2, because the square root of 25 can come out, but the 2's left behind. Over here, I have square root 20 and square root 9. I already know the square root of 9. What's the square root of 9? 3. Square root 20 is 4 times 5. So this 4, I can take the square root, so it's 2 square root 5. Number 7. What am I going to do with number 7? Right. Right here, can 5 divide into 125? Yeah. So the square root 125 divided by divided by 5 is just 25. Does everybody agree with that? Oh, that'd be 2. Yeah, 25 would be 5. So when I divide this, it'd be like saying you'd have 1 on top because you still need a number up on the numerator. And then this would be square root 25 because I divided that 5 into 125. But what is the square root of 25? 5. So that would be this reduced. Well, you're reducing fractions. Just like if you had 2 4s and I'm reducing that, that's 1/2 because you divide both these by 2. So here you're dividing by square root of 5, right? To simplify, which this would just be 1, and then under here it would be square root 25. That's how I end up doing it, but it's wrong. Oh, but this would then cancel out. True, right? The square root of 5s would cancel out. So that'd be 1/5. You could have done it your way. Okay, so let's go ahead and divide. What number can divide into 15 and 20 equally? 5. So this would be square root 3 over square root 4. But I know the square root of 4. So that would be square root 3 over 2. But before I move on, I'm going to add one more down here because this is going to come up a lot on Thursday. And so I just want you to understand. If I have this, I can't leave a square root in the denominator, right? What do I do to both the top and the bottom so I can get rid of that square root on the bottom? Yes? Right. Since I know square root of 2 would cancel out this radical, you multiply both top and bottom by the square root of 2 over the square root of 2. Because this is 1. And you can multiply anything times 1 and still get the same answer. This just looks like, I used to tell my students, a funny looking 1. It is 1, but I need to do this so I could it's called rationalizing the denominator. Now this denominator has what we call a rational number. Square root of 2 is an irrational number. And now I could leave it like this, right? So let's say I had something like this. What would I have to do? I'd multiply both by the square root of 6. Now when I multiply by the square root of 6, this becomes 5 square root 12 over 6. But 12 has a perfect square in it. What perfect square is in the number 12? Square root 12 is equal to square root 4 times 3. This 5 is on the outside, though. So when you take the square root of 4, which is 2, you need to multiply that 5 times 2. So that would be 10 square root 3 over 6. However, I'm still not done because what do you notice about 10 and 6? Yeah, 10 and 6 can be both divided by 2. So when I reduce this fraction, it's going to be 5 square root 3 over 3. You could have done 1 here. Yeah, I mean, you could have just done square root 3 down here too, and then just multiplied top and bottom by square root 3. Either way would have worked. Any questions on rationalizing denominators? You cannot leave square roots in a denominator because square roots of non-perfect squares are called irrational. Okay, now flip the paper over. Who was anybody not here yesterday? Everybody was here yesterday? Oh, you were not here, but you got your work already. Okay, let me get you the notes. I emailed you the video. Did you get the video emailed to you? Kenny? It should have even gone to your private email too. Okay, so there are three geometric means of right triangles, right? Let me see if I could draw. This is going to have a triangle. Oh, it's not going to be a right triangle. No, I want it to be a right one. Let's see. Make it smaller. Almost right. I can get it to be right. Oh, uh, it's not as close. That's about as close as I could get it. Okay, so if I have a right triangle and I draw an altitude, which is an altitude means that it's perpendicular, right? You have three geometric means. You have the leg of the outside, the other leg of the outside, and the middle piece. All three of those are geometric means, right? And I gave you notes, and there were three cases. If I'm talking about the middle geometric mean, like number one, geometric mean, if I set up an equation, I'm going to see this geometric mean twice, right? So I see it up and I put it down. Now, it cuts this hypotenuse of the big triangle into two pieces. You're going to use those separate pieces for the other two numbers when the geometric mean is in the middle. So I'm going to do x and 9, right? It doesn't matter. I could have done 9 and x. Now I'm going to cross multiply. 9x equals 144. I don't have to take the square root. I'm just dividing by 9 on this one. So the answer is B. X is equal to 16. Over here, though, the geometric mean is on the outside. And when it's on the outside, you use the part of the hypotenuse that's touching and the whole thing. So this is the geometric mean. You're going to put this two places. You're going to put it up, and then you're going to put it down. And you have your pieces. You have your 56, and you have your x. Did I lose anybody there? Okay, I need to multiply on the diagonals. So if I'm taking 18 square root 14 times 18 square root 14, that'd be 18 times 18. I'm splitting them up. Times square root 14 times square root 14. What happens with these square roots? This just becomes 14. So you do 18 times 18 times 14. It's going to be a huge number. What is it? I did. Yep, I did this earlier. 4, 5, 3, 6. Now that's going to equal this side, 56x. So you divide by 56, and x is equal to 81, which was A. So you have to set up your proportions correctly. So this one, though, I have to do a step before I can set up the proportion. Here's the geometric mean, right? It's on the outside. This is your geometric mean that you see on top and on bottom. But you use the side it touches in the whole thing. Well, the side it touches, I don't have a number there. So how am I going to get that number? Yeah. If I take this 49 and subtract 9, this is 40. Because 40 plus 9 has to be 49, right? So I'm going to use 40 and 49 because you use the part of the hypotenuse it touches, and then you use the whole thing. So I would use 40, and then I'm going to use 49. So I get x squared equals. Now I'm going to be smarter than the average student. I'm going to keep it like this because I know that the square root of 49 is what? 7. So this, when it comes out, would be 7. Is there a perfect square in 40? 4 and 10. What's the perfect square of 4? 2. So that comes out. So 2 times 7 is 14. And the one that was left behind was the 10. And there's no perfect square in 10. So it'd be right here. If I multiplied 49 times 40, I'd get this huge number, and it'd be hard for me to simplify. So I kind of kept it a little separate because I knew that 49 was a perfect square. Does that make sense? Yeah, I just kind of broke it into pieces instead of a really big number underneath that radical. So if I'm looking at number 4, where's the geometric mean? Is it the 4, the 12, or the x? It's the x because it's the outside of this big triangle. And if it's x, I have to use the side it touches and the whole thing. But what is the whole thing? Because it didn't give it to that. Yeah. Since it just gave us the 2 pieces, I have to add these 2 together, and I would get 16. So when I set up my geometric mean, I do x up, x down. One number is going to be 12. The other number is going to be 16. And then I'm going to cross multiply. X squared equals, again, I'm going to be smart and try to reduce without multiplying and making these numbers huge. What is the square root of 16? 4 can come out. Is there a perfect square in 12? 4 times 3. So when I pull this one out, right, what's the square root of 4? That's going to be 2 on the outside and 3 left. So 4 times 2 is, so x is going to equal 8, and the 3 is behind. Is that one of these? Yeah, its number is letter C. Yes. Yeah, you needed to use okay, so the geometric means the x. When it's on the outside, you use the side of the hypotenuse that this x touches, which is the 12, and then the whole hypotenuse, which is 16. Because 12 plus 4 is 16. Oh, because the 3 geometric means are the legs of the big right triangle. So it'd be this one here, it would be this one here, or the altitude, the middle one. It's never on this hypotenuse. It's always the outside legs. Great question, Hassan. Great question. The others? I know these are trickier to get to see sometimes. Are we having a quiz Thursday? No, we're having a quiz probably Tuesday of next week. Um, will I be here on Friday? Will any teacher be here on Friday? No, we have to go downtown. So don't come in on Friday expecting to make up a test. You'll be sorely sad because there will be no one here. Okay. So, what's the geometric mean on number 5? X. And it's the side it touches and the whole thing. What is the whole thing? 36. I had to add those two pieces together. 16 plus 20 is 36. So you're going to have X up and X down because it's a geometric mean. You'd use the 16 and the 36. Again, I'll probably be smart because aren't those both perfect squares? So wouldn't it be easier that when I take the square root of this, it would just be the 4 comes out and the 6, and you multiply those. So you take the square root of 36, and that'd be the 6, and multiply 4 times 6 is 24. Bloop, 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 bloop.
I didn't mean 50, 60, 36 plus 24.
Excuse me?
You said 36 plus 24.
Times. That's the times.
Okay. This is big enough.
6 times 4 times 6 is 24. Okay, now we're going to do trigonometry. This is my favorite lesson. Hopefully it'll be your favorite lesson. I want everybody to look at their calculators while I'm handing this out. And I want you to see if you can find sine as S-I-N. We don't send in math class, so we call it sine. Cosine and tangent. Look at your calculators right now while I'm passing out the notes. See if you can find them on your calculator. And you want to, if you're using my calculators, you're going to have to change it to degree mode before we start. I'm going to teach you all how to do that. Okay. Before we start, there's going to be a lot of confusion if we all don't check this first. Everybody who has one of these calculators, want your eyes up here for a minute. Everybody paying attention? You will get the wrong answers if you do not change the mode on your calculator. The mode always gets default back to radians. We want it as degree. So do you see mode right here next to your second? You don't have to worry about it. It's just if you have these calculators. So go ahead and go to mode. Do you see here where it says radian? We do not want radian. We want degree. So you have to pop down. When radian is flashing, you have to push it over and press enter. So I'm going to walk around. I'm going to check all the graphing calculators. Yes, you would. You just want to scroll down to, you use the down button because you start out up here flashing. You just scroll down to where it says radian. You scoot over and you want it as degree. If it's not in degree, you will get the wrong answers because radians are used for trigonometry, not geometry. So, mode, you were already in degree. You are not in mode. You gotta go to mode and go down to where it says radian. Over. Now press enter. You're good. You're good. You don't have to worry about yours. Yours are always calculators are separate. Let's see. Okay, but if you don't get the same answers, we're getting, let me know, because then so, good. Everybody here has the right mode? Yep. Now you go to second quick to get back home. Good. Go second quick to get back home. You're in degree. Scroll down. Push down. Push over. Second quick. Scroll down. Now see how you're reading. Now press enter. Uh-huh. Read. You guys did it right. Okay, and then if you hit second quick, then you'll get that one. Second quick. There you go. We good now? Okay. I couldn't start without making sure everybody was in the place. Because if you're not, and you have to remind me because this calculator on the computer always resets. And so every time I pull it up, I have to change it to degree. Um, how come it's not letting me open with Cami? Yeah, I was wondering if that's why it wouldn't open for me. I think that's what it was. I was using too much memory. Okay. The functions I'm going to teach you today can only be used on right triangles. Now, there are other formulas using sine, cosine, tangent that you don't need right triangles, but that isn't a geometry standard anymore. It used to be, but it isn't anymore. So we are just going to focus in on the formulas for right triangle trigonometry, okay? You'll never change your life until you change something you do daily. The secret of your success is found in your daily routine. Do you agree with that? Yeah, I do too. Okay, somewhat. Okay, so I don't know why they have 70% mastery. I aim for 80% or better. Most of you have been doing really good on your tests and have been doing that, so good job. Okay, so sine, cosine, tangent. On your calculator, and go back to second quit. On your calculator, you have sine, which is SIN. Look and see if you can find it. You have cosine, which is COS, and you have tangent, which is TAN. Now, I will always giggle when you say sin instead of sine, just because I'm silly that way. We don't sin in math class. We sign in math class, okay? It actually has an E at the end, but there's not enough room on here, I guess, for the E. What's above it? Look above these. Do you see how it has to the this one says sine to the -1? Look at your sign and look what's above it. To the -1 power means inverse of. We will be using those to find our degrees. We use the plain ones to find sines. We use the ones above to find degrees, and we'll go over that slowly when we get to that, okay? We will use these for ratios. Now, when I say sine of a degree or sine of a ratio, that's a stored number in your calculator. It's an actual number. Mathematicians years and years and years and years ago did meticulous measurements, meticulous, and they did it for every single degree, even partial degrees like 0.5s. When I first started teaching, because I am that old, they did not have scientific calculators for everybody. They used to be very, very, very expensive. So everybody just had the little four operation calculator. I would have to print out tables when we got to this unit so that every person had a table of all the sine trigonometry functions, okay? But now we are lucky because they store it in a calculator. And so these are just numbers that are stored in your calculator that are ratios, okay? So we will use them to find missing sides and angles. I could have swore that I updated that and put angles too. I think this one is it. Trigonometry is a branch of mathematics that studies relationships between side lengths and angles of triangles. It's a whole branch. You can take full trigonometry classes. This is just one lesson of trigonometry. Okay? Oh, do I have any more? I don't know if I have any more. Is there any other ones back there? One in my good employees. Here's two. I think I have four more or two more. I'll have to get others. Is that the only ones that are there? Is that the only one? You may have to share. Sorry. Okay. Now, to do these correctly, remember when I had you label for Pythagorean theorem and you labeled A, B, and C? You are going to be labeling again, but it's in reference to a certain degree. You'll be putting your finger on a degree and then labeling a triangle based on that. Remember that we have legs of a triangle that make the right angle, and across from the right angle is always your hypotenuse. And your hypotenuse is always your longest side. Okay? I don't think here you have to write anything yet. Oh, right here. There are three trigonometry ratios, sine, cosine, tangent. No, you're not writing anything yet. Okay, here's the ratios you have to write on your paper right here. I'm on still the very first page. You're in the middle. It says trigonometry ratios. Write the ratio below. So this is what you're writing. You could put an X or you can use theta. Theta is a Greek letter that's used for degrees. So sine of theta or X, you can put an X if you want to, equals opposite over hypotenuse. Cosine theta equals adjacent over hypotenuse. Tangent theta equals opposite over adjacent. So because it's a right triangle, I will theta's ratio ends up staying the same no matter how they word it. Okay. When I'm talking about opposite and adjacent, it's always in reference to the angle that they're referencing. Because if I go to the other angle, it's going to be different. So if I put my finger on theta, the reason why this one's called opposite is it's opposite of this degree. Do you agree with that? Hypotenuse always stays the same. Hypotenuse is across from the 90 and is always your longest side. Adjacent's the one that students get a little confused. It's the side, it's the leg that helps metal, right? But it's not the hypotenuse. So I always label adjacent last. Because if I label opposite and then I label the hypotenuse, then it makes sense that the last one will always be adjacent. But adjacent, remember adjacent next to, this is next to the angle, but is not the hypotenuse. Hypotenuse. Or some people will call it hypotenuse. So, or hypotenuse. So it's always in reference to the angle that you are talking about. So did everybody write these down? Because you will be using these over and over and over and over again. Here you go. Can I move? Nope, we're still. Okay, can I go? Like right here? Okay. Okay, can I go now? I can move now, right? Okay. Some people use the mnemonic aid of SOHCAHTOA to remember sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. Do you see SOHCAHTOA? That's why they SOHCAHTOA. That's just a mnemonic aid so people remember. SOHCAHTOA.
Spanish.
It's just a mnemonic aid. Sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. See how that works? Okay. So I just wrote that down for you. So let's look at some of these, which I think I have on the back here. When it's just asking for a ratio, you're not trying to solve anything. They just want the ratio. So you put your finger on the angle that they are talking about. Here's X, right? Here's X. Everybody put their finger on their X? Okay, what's opposite of X? 3. So I'm going to put opposite. I use OPP for opposite. Okay, now I always do the hypotenuse next. Which one's the hypotenuse? It's always across from the 90, longest side, hypotenuse. So what's the leftover one called? Adjacent, which I'm going to put ADJ. See, I always label my triangle before I start. Now, it's saying sine of x has to equal, and it's going to be a ratio, meaning I'm going to have a fraction. What number again is opposite? 3 is opposite, right? And then what's hypotenuse? 5. So the ratio, if I ask for the ratio, the sine of x, I would say the ratio is 3/5. Any questions on that one? Yay, nay? Let's try this one. I'm going to go to x again, and I'm going to label. Here's x. What side is opposite of x? 40. So this is OPP. What side's my hypotenuse? And what side's my adjacent? 9. Anybody confused on how to label? You put your finger on the letter they're talking about or the angle. I'm going opposite. Then I do the hypotenuse, which is always across from the 90. And then I'm going to label the adjacent. So cosine of x. Now I'm going to put adjacent over hypotenuse. Where's adjacent? 9. What's hypotenuse? 41. You should reduce your fractions, but so far we hadn't had any that we needed to reduce. Okay, so now I'm going to do tangent. Where do I put my finger? Where am I putting my finger? It's on the Z. They messed with you. Okay. Now, where's opposite of Z? 20. What's the hypotenuse? And then what's left over, we label that as adjacent. 21. Remember, adjacent helps make the Z, but is not the hypotenuse. So that's why that's 21. So tangent Z is equal to opposite. What number? 20 over 21. And I don't think that can be reduced either. That's it. Okay, so now I think they do a couple more. I'm just scrolling to see what we're doing. Okay, and then we're just still practicing, right? What number are we on? Number 4? Okay, where do I put my finger? A. I label. Which one's opposite? Which one's hypotenuse? Hypotenuse is always across from the 90, and it's always the largest side. And then what do I label as adjacent? 14, because it's the leftover one. So cosine of A is equal to 14 over. Can this one be reduced? Yes, you need to divide by 2. So this would be 7 over 25. Or you could put 14 divided by 50, math, enter, enter, and it reduces it for you. Okay, just a couple more practice on this, and then we're going to actually use it. Okay, where do I put my finger? I put it on X. I'm going to label.
24 is opposite.
Yep, because I cross the street as opposite. I label the hypotenuse. Hypotenuse is always across from the 90. And then I have my adjacent is the 7. So tangent of X is equal to 24 over 7. Can this be reduced? No. It's improper, but that's okay. In higher level math, most of the time you leave things as fractions, but you reduce. Okay, one more. Where do I put my finger? A. So my finger's here. Where's opposite of A? 35. What is your hypotenuse? And where's adjacent? You guys have been doing this forever. No, you've only been doing this for 5 minutes and you already got it down. That is awesome. Anybody confused on how to label? You always put your finger on the variable and that they're talking about, and then you label, because that's half the battle. You got the right fraction. That's like half the work. So I would do 35 over 37. Okay. So we're going to be setting up cross multiplication again. We've been doing that an awful lot lately. And it's always from the angle measure that we label. So like if I was to do this one, here's the angle measure, right? I would have labeled opposite. I would have labeled hypotenuse. And then I would have labeled this as adjacent. Now, I would have, let's say I didn't see that it was sine. They don't usually tell you which one to use. You circle the side you're looking for and the information you have. Then you'll have your list, SOHCAHTOA, sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. You would look and you'd say, well, which one of these uses opposite and hypotenuse? And you would look, and because we don't sin in math class, we sign in math class, you would say sine. And you would use the degree that we labeled from. It would be sine of 24 degrees equals x over 283, right? I would place this over 1. And I would cross multiply. When I cross multiply, I get x on this side because 1 times x is just x. And then over on the other side, I get 283 times sine of 24. Now I went around and I checked your calculators to make sure you were in degree. Mr. Brandon, you need to check your calculators for this lesson. If your mode, when you turn it on, because mine will, anytime you need to change it to degree. Because if it's in radians, they'll get the wrong number. So check your calculators in your room. Okay, so now I would just put this in my calculator. Everybody have their calculator out? 283. You could put times, or you could just put it right next to it. Sine 24. And then press enter. Make sure you get that 115.1 because I want to make sure everybody's calculator's set to the right mode. So everybody do that right now. Make sure you get 115.1. Is that what everybody got? Good. You did not get this. Let me know. I need to look at your calculator. Oh, you're in scientific mode. Anybody else not get that answer? Oh, they just rounded. Write that on the calculator. I just changed your float. You had it cutting off at the whole number, so you weren't seeing any of the decimals. Okay. Swear I have to have a master's degree in just using different people's calculators.
I have a question. So does that mean every single time if there's a degree, that's where we start off?
Yes, that's what I'm doing next. Okay, so question number 7. This is typical. This would be like what you'd see on a standardized test. Where do I put my finger? At the 29. Wherever the degree is where you put your finger. You label the whole triangle. What's this one? Opposite. Where over here is hypotenuse, and this is adjacent. Now, circle what you're looking for and the information you have. That tells you which one you're going to use. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's what the SOHCAHTOA means. So which one am I going to use if I circled adjacent and hypotenuse? No, adjacent. Cosine is adjacent over hypotenuse. So you would do cosine 29 is equal to 20 over x. Now, in this case, we're going to have to divide because my x is in the bottom. Anytime your x is in the denominator, you should do a little star on this, near this, that when x is in the denominator, we end up using division. When x is in the numerator, we end up multiplying. But I'm going to show you why. When I cross multiply here, I get x times cosine 29 equals 20. This is just a number stored in the calculator. Remember me talking about that? It's just a number. What am I going to do to both sides so I can get x by itself? I'm going to divide by cosine 29. So x is equal to, now I'm going to put this in my calculator. So I am going to just check my mode because sometimes my calculator, I'm good. I'm in degree. So I'm going to do 20 divided by cosine 29, and then I press enter, and it would be about what, 22.9? It should be approximately because I rounded. 22.9. Make sure you're able to get that in your calculator.
Can you please repeat again? Real good.
Okay. Do I have to go from the start?
How to go to calculator?
Oh, just how to put it in the calculator? So, to put in the calculator, this is 20 divided by cosine 29. So you put 20, divide, and then you press cosine, and then you do 29. I always end my parenthesis and press enter.
Okay.
Did you get that? Nice. Did everybody get 22.9? Yes. Anybody need me to look at their calculator?
Yeah, God is still in here.
um,
It's
do you mind taking some tissue and getting that stink bug because that's freaking Anna out? There's some tissue right up here. Or somebody.
But I was born, like raised in the country.
I know. I'm like, I was in Arkansas. I'm like,
Did you kill it? I grew
oh,
up on
just
a
so
farm in Kentucky. Well, it's done now.
She didn't mind squishing it. Okay.
I have done it. No, sorry.
So let's do number 8 together.
Finger on the 70.
Give the triangle your finger. Yes. Put your finger on the triangle.
The opposite is X.
Okay. So the opposite of 70 is X. So that's opposite. Where's hypotenuse? Is over here. I still label it. And then this is adjacent. Now I circle. I have adjacent. I'm looking for opposite.
We're doing tangent.
We'll be doing tangent because tangent is opposite over adjacent.
70 equals X over 60.
Geez, they're saying it faster than I can write it. Tan of 70 is equal to X over 16. So now I'm going to put a 1 under here and I'm going to cross multiply. And this is easy because this is just multiplication because X is on top. So 1 times X is X. And then I'm just going to take 16 times tangent 70. Notice how I usually put the trig at the back side. I do that because if you forget to end the parenthesis, you'll get the same answer. But if you put it in front and forget to end the parenthesis, then you don't get the correct answer. So that's why I always write the trig function at the back. So what's the answer?
Approximately 44, I think.
X is approximately 44. Yep. It would round up because it was like this. It was 43.95. Well, this 5 bumps the 9 up, but 9 would have to bump this one up. So it'd be 44. Do you like the trig? I thought everybody liked this one. This is usually one of my students' favorites. Okay, so I don't usually rhyme, but I rhymed. I made up a little song for you all. Finding missing angles. Use the inverse of the trigonometric function by pressing the second key. So, when looking for a degree, use the second key. See, it rhymes. When looking for a degree, use the second key. So we have to do the inverse. We still have to label everything. This is the degree we're looking for, right? What's this? That's opposite. What's this over here? Hypotenuse. And what's this over here? Adjacent. Now, I'm circling where I have my numbers because that will tell me the trig function I have to use. You wrote them all down, right? This one's sine. So it's sine. You can use an x. I'm going to use a theta just because I'm a math person. And I'm going to put opposite over hypotenuse. Now, when you watch carefully, do I have all eyes up here? When you're putting it in the calculator, because you're looking for the degree, you hit the second key. So I'm going to put second, then I go ahead and go to sine. See how it has that little -1? Okay, and then I go 33 divided by 58, and then I press enter, and that would be the degree. So, and here, it usually says round to the nearest whole number for degree instead of tenth. So I would label this as about 35 degrees. So when do you use the second key?
To find the degree.
For find the degree, you use the second key.
Nice.
Okay, so here's another example. Here's where I'm going to put my finger, right? Okay, and I'm going to go opposite. Hypotenuse is here. What do I label 24 as? Adjacent. Now, I have opposite and adjacent. What trig function uses opposite and adjacent? So tangent of theta, or you could put an x, is 24 over 57, which is actually 1/2, but it doesn't matter, your calculator. So hit the second key, remember, because you're looking for a degree. So you don't go second, tangent, 24 divided by 57. About 23 degrees, yep.
It should be 57.
Opposite over a, oh, I did this backwards, didn't I? Ooh, it's 57 over 54.
Oh.
Or 24. Yeah, it should have been opposite over adjacent. Sorry about that. So it should be second tangent.
67?
Is that what you got? 67? Yeah, you did it the correct way. I made a mistake. So theta equals 67 degrees. Okay. I'm just looking. Okay, I was just looking at how much I have left. Okay, we're going to do one more degree. Then we're going to remind you how to do the sides again. And then a word problem. This word problem is like what we're going to do outside tomorrow. So please be here on time tomorrow or you're going to miss the how to do this. Today, I want you to figure out which groups you're going to be in, 3 to 4. I want you to practice in the hallway how to use your measuring tool on your phone to find meters. So, because someone in your group has to, all Apple phones have a measurement. Android, you have to download a free app. But if you have, but I want you to practice with your group today because I don't want chaos tomorrow. I've done this way too many times and I end up getting chaoses. And I got to get a handful of nuts out of my husband's garage so you guys can make the inclinometer. gotta remind myself to do that. Okay, so so we're gonna do this one, right? Have we done this one yet? No. Okay, put your finger on the degree. Label your triangle. What's this one?
Opposite.
Opposite. What's this one? Hypotenuse. And then this one is adjacent. Now, circle, you have opposite and adjacent. You're looking for the degree. What is opposite and adjacent? So tangent theta is equal to opposite over adjacent. So, or is it yeah, opposite over adjacent. So it's 26 over 44. Now your calculator will handle it. So just go second on your calculator and put 26 over 44 in there. What do you get?
90.5.
Did you do second? Tangent. Make sure you have that -1. 26 divided by 44. And we get about 31. So approximately 31 degrees. Okay, now we're going to go back to finding a side length because some people then will do second button on everything if I don't do this. So, are we looking for a degree this time? No. Are we going to use the second button on this one? No. We still label from this degree. What's this side over here? Opposite. This side is hypotenuse. And this one's adjacent. You don't have that one?
No.
Do you want me to continue it?
Yes.
Okay. So I'm looking for a hypotenuse. I have adjacent. Which one's adjacent and hypotenuse? Cosine. Cosine is adjacent and hypotenuse. So cosine 20 is equal to 15 over x. Do you remember when x is in the bottom? Do we multiply or divide in the end? Do you remember? You'll end up dividing. But this is why, because you get x times cosine 20 has to equal 15. And now you're going to divide by cosine 20. Divide by cosine 20. So x is equal to 15 divided by cosine 20. And so use your handy dandy calculator. 15 divided by cosine 20 is about 16. Yep. Okay. So this is basically what you guys are going to be doing. And this is why you need groups of 3 or 4. What?
I was just surprised that we didn't have a find a degree one for the cosine.
I don't know. It was all generated.
it's
I
the
don't go
same
through
way.
each one.
It's the same way though, right?
Yeah. Using my protractors, and if you remember, I had to take strings off and take off straws. If you were here early on some of the protractors, and the reason is we're going to create an angle of elevation finder. You're going to be using it to find an angle looking up. Now, I looked on Amazon to see how much those things cost because, believe it or not, if you were a surveyor or worked in the forestry, if you wanted to know like how tall a tree was, do you think that's usually something like someone who works in the state parks and stuff want to know? Yeah. So, and then people who remove trees need to know that too, so make sure it doesn't fall in someone's of someone's roof. So they actually have devices that will measure. They were like $40 each. And I can just take a couple straws, a piece of string, and some bolts, and we can make the same thing. So what you will do tomorrow is everybody's going to do their own angle of elevations. You're going to work in as teams because you need help in getting your measurements. But not everybody's math problem is going to be the same. In the end, hopefully you all get the same height because the height should be the same. But our heights aren't the same. I'm pretty short, right? You will need your eye height. And the reason why you need your eye height is if I'm looking up here at my angle of elevation, when I make my triangle, see here, I'm using my height. So you'll add back in that eye height from your eye down. You will find this measurement. That's why you need a measurement tool with your phone. I have a couple longer ones, but I only have 3, and this is the biggest geometry class I've had at the Excel Center. So a lot of Apple devices have measuring tools on their phones already. Yes.
What's the measurement app that we download if we don't have it?
Look it up online. Just go to your Play Store and just put measurements in meters. But find a free one. Don't get one of those trials. But you'll be in groups of 3 or 4. So if you don't have an iPhone, hopefully someone in your group has an iPhone. Okay? You will be measuring the distance from where you're taking your height, your angle of elevation. We're going to do in meters. We will use trigonometry to then figure out how tall something is. We'll all be using the tangent function for that because it's going to be opposite and adjacent. So let's go ahead and do this problem and circle this. This is what you're going to be doing tomorrow, basically. And I'm going to have people out in the hallways practicing finding the measurements and all that because I did it. And I kind of know approximately how many meters this is. Not right now. Let me do this, and then when we start going out to practice, I will, because I want to do the problem first. Okay, so a math student is standing. We're going to do it all in meters, just because it's easier for your eye heights and everything with decimals. But this person's 25 feet away from the base of Washington Monument. The angle of elevation would be right here, right? So if I label my triangle, this is opposites here. Your adjacent would be here. This is your hypotenuse. You are looking for the height, so you're looking for your opposite. You have adjacent. You also have this angle measure. Now, the angle of elevation from her horizontal line of sight is 87.4 degrees. Boy, she must have used one of those really fancy ones. We're not going to be able to get 0.4. We may come close, like to the nearest 5 degrees, because we're going to have little rough estimates. Has any of you guys seen the people that are outside, like on the roads with the tripods, with the big yellow vests? This is the math they're doing, people. A lot of this is done with, so if you end up liking this, there's a lot of good jobs working with the city or with like engineering firms on what's called surveying, where you are laying everything out and finding all the measurements. And they're using drones so nowadays too. So if you want to play with drones and do some math, look into surveying. There's an actual shortage of surveyors. My son is working for a company. He's done a little bit of surveying, but he's a CAD drawer now. So anyway, side note. So what would I be using with opposite and adjacent? Tangent. And so this would be tangent 87.4 has to equal x over 25. I'm going to cross multiply. You would get x equals tangent 80. Oh, I forgot my 25. Ah, hold on a minute. Where's my eraser? I don't have my glasses on. That's the problem when I. Sorry. 25 times tangent 87.4. What answer do you get? 551, 551 feet. But what else do we have to add? This is from here to here. You have to add her eye height. What was her eye height? 5 foot. So you have to add your 5 foot, and that will give you your distance, which was what? 556 feet. I wonder, we'll have somebody do their research, see how tall the Washington Monument is, see how true this word problem was. I'm wondering if it's correct. So tomorrow you will be like choosing, there's lots of light poles outside. There's trees, there's buildings. What? 500 and what is it? 55. We were off by one. Oh, not too bad. Okay. So I'm going to give you time to practice. I'm also then going to have you guys sign up for groups. So make sure you are here tomorrow. You do not want to try to make this up on your own. And it is part of your final exam. So just be here on time, not late. On time is 9 o'clock. Bring a jacket just in case it's cold. Bring 2 jackets. To bundle up. Okay, please take till 10:30. We have word problems and yeah, with these. Hello. Go ahead, go back. Oh yeah, I hope so. That's one of my son's favorites. And now you're in the bar, so I'll be able to see you.